Now over here we have an air balloon which starts rising with an acceleration of 1.25 meter per second square. Initial speed is equal to 0, and after some time, that is t is equal to 8 seconds, a body has been released with respect to it. That is, initial velocity of this body with respect to this balloon is equal to 0, or with respect to a person on the ground, this body has some initial velocity which can be given by v is equal to u plus at. And the velocity of this body is same the velocity attained by air balloon in t is equal to 8 seconds when it had been moving up with the acceleration of 1.25 meter per second square. And the velocity of this is u plus at. Initial speed, it was 0 of the balloon, so obviously of this body was also equal to 0. So v is equal to u plus at. A is 1.25 meter per second square, t is 8, so this comes out to be 10 meter per second. And at what height this balloon will be at t is equal to 8 seconds, we can use s is equal to ut plus half at square. So s is equal to ut plus half at square, so h is equal to u is 0 because initial speed was 0, now it is accelerating up with 1.25 meter per second square, half a t square, so this h comes out to be 40 meter. So this h comes out to be 40 meter. Now at t is equal to 8 seconds, or at a height of 40 meter, this body is projected up, and we are asked what is the time it is going to take to reach the bottom. We have various options. Let's find the time first. So it means from this tower, which has a height of 40 meter, it is equivalent to, that is, a body has been projected up with a velocity of 10 meter per second, and let's find the total time it takes to go from here to and to reach the ground. We take the vectors in the upward direction as positive, in the downward direction as negative, and we apply s is equal to ut plus half at square. So displacement from here to here, that is initial point of observation, and this we take it as final point of observation. The body has gone from here to here. We are not bothered what happens midway, whether it is going up or coming down. We are just bothered displacement, and for displacement, connect or join the initial position to the final position through a straight line. This is moving in a straight line. This is just to show that is we have made some distance between the two, but otherwise this is rectilinear motion. It is moving in a straight line. This is not a projectile motion. So from here to here, when we draw and we are bothered with displacement, it has to carry an arrow on its head. So it is like this. What is this distance? This is 40 meter. Direction is downward, so it means it is going to be minus 40. What is the initial velocity? S is equal to ut plus half at square, and we are going from A to B. Initial velocity at the initial point of observation, that is at A, 10 meter per second in the upward direction, 10t plus half, accident due to gravity is always, vector is always directed downwards, and if we are sticking to this sign convention, then g is taken as negative, and we are taking g as 10 meter per second square in the downward direction, so that's why it is negative. And when we solve it, we get the value of t as plus 4 seconds only, because the time negative, that is certainly extraneous roots, that is not possible. So the permissible time is t is equal to 4 seconds. So it means this body which is released from this balloon, which is moving up with the acceleration of 1.25 meter per second square, and at this instant when it has a velocity of 10 meter per second, and it is at a height of 40 meter, this will take t is equal to 4 seconds to reach the ground.